Hello. This lesson will continue to talk about the factorization of some simple expressions. Let's revise the concept of factorization. We know that when I say x times y, then we know that x and y, we can say they are factors. But when we meet 2x plus 2y, because it's the sum here, right? So you know that 2x, 2y, they are not factor. To produce factor, so you find that you can take out 2, then x plus y. Now you find that because it's 2 times x plus y, so in this case, 2 and x plus y, both of them we can call factors. As a result, when I say 2x plus 2y, the factors only 2 and x plus y, right? But not 2x, 2y. You need to be careful. And let's revise the relation here. So you can say that the factorization is the reverse process of expansion here. Last time we know that we only take out the common factor to perform factorization, but in fact we can use the identities to also help us to perform factorization. So in this part, we would like to try to use the identities to perform factorization in some expressions. Let's revise here. Let's revise. We have learned 3 identities. One is when a squared minus b squared, that means the difference of 2 squared. Then you know that when I say a plus b times a minus b, then it will become the a squared minus b squared. And also we learn the perfect square. When I say a plus b squared, then it can become the a squared plus 2ab plus b squared, and a minus b squared can become a squared minus 2ab plus b squared. And in this part, we would like to focus to use this one to make the factorization. When we want to use the difference of 2 squared to perform factorization, of course, we need to make sure that the expression can become the difference of 2 squared. For example, when I say x squared minus 16, then you know that it can become x squared minus 4 squared. And you know that when a plus b and a minus b equals to a squared minus b squared, we know that it is the whole a, the square whole a here, right? That means everything in a you must take square. So in this case, when I make 9x squared here, the square only control the x only. So we need to do something such that it is a square of whole. And we know that here, when I say 9x squared, it can become 3 square x squared. That means it can group together 3x and square to the whole. So that means when I say 9x squared, it is a square of whole 3x, right? So that's why 9 squared becomes 3x times 3x. Of course, 4 can be 2 squared, so that's why it become this 2 squared. Okay. So we know that when a plus b times a minus b, it can become a squared minus b squared. And because it's an identity, so when a plus b times a minus b is identical to a squared minus b squared, then the same way, when I give you a squared minus b squared, of course we can go back to become these two factors, just because it's identity. So the factors can become the square minus square. Of course, when square minus square, we can go back to give me the 2 factor. So in this case, when we meet from this identity, we learn that when we meet the square minus square, then you find that it can break down to these two factors, okay? These two factors, because you know that these two are product, so you know that these two is a factors. For example, when x squared minus 16, it can become x squared minus 4 squared. You know that for all square minus square, you can break down to the product of these two, okay? When a squared minus b squared, you can break down to a plus b, a minus b is a product, okay? So a plus b, a minus b are the factor, okay? So in this case, it's a x squared minus 4 squared, so you can break down, you know, it's x squared, 4 squared, so you can become x and 4, but 1 plus, 1 minus. It's like this. So let's try to do some more examples here. The first one, when I say x squared minus 121, is x squared, and 121 is the 11 square. Okay, let's write down the identities here. Well, now you've after this, okay, you found that this expression can become square minus square. That means you match this one. So you know that for all square minus square, it can become these two factors. That means this one can have two factors, have x, have 11, but 1 plus 1 minus. That means the x squared minus 11 squared can become x plus 11 times x minus 11, okay? So you find that this one can break down to the product of these two. So you know that these two are the factor. You become the product of these two factor. So it is the factorization result. Now, let's consider this example. 49 minus 16k squared. So the first job, we want to study these two can be, if we can become the square, something square. 49, so obvious, we can become 7 square. And for 16k squared, just like before, this square only control the k only, right? But not 16. But you know that when we want to use the a squared minus b squared, the square must control the whole b, right? So that means everything in b, you need to become something square. So in this case, so for 16, we know that is 4 square. Okay, k square. As a result, it is a 7 square, and this one can become square of the whole 4k, okay? So this one will map everything in b, take square. Well, now it becomes square minus square again. That means it is a a square minus b square format. And from the identity, we know that this square minus square this one can break down into two, the product of two factors. And one is 7, one is 4k, and 1 plus 1 minus. As a result, it can be break down to 7 plus 4k times 7 minus 4k. Consider this one. For this term, okay, you find that it is a square of x plus 1, okay? So, just like before, we know that when I say a squared minus b squared, a can be anything, include can be expression. So that means this one is a square of the whole x plus 1, okay? Now, consider this. We know that 36 can become 6 square. So, after that, you find that this one is also the square minus square. Square minus square. As a result, we can also apply the identity, which is when I say square minus square, then it's so that means that we can use these two to perform two factors. One is x plus 1 plus 6 and x plus 1 minus 6. But be careful. In these two factors, you find that there exists the like term. They are like term, okay? So you know that both of them is no x term, okay? When you meet the like term in a factor, then you need to calculate here. So in this case, x, but 1 plus 6 can become plus 7. and x, okay? But this one is plus 1 minus 6, right? 1 minus 6. That means that this one it will be, after calculation, become minus 5. As a result, this one, after factorization, it is a product of x plus 7 times x minus 5. Now, let's consider others. This one you find that it's not easy, because when you study 75 and 48, you find that both of them you cannot become the perfect square. Or you can say no integer when take square it can be 75 or 48. But when you study these two numbers, you find that both of them are multiple of 3. Multiple of 3. So that means you before next action, for these two constant, you find that you can take out 3. Take out 3 as common factor. And 3, that means for 75, when you take out 3, that means because remain 25 a square. And then 48, when you take out 3, that means you divide 3 after that. So when you take out 3, remains 16 and b square. Now, after you take out 3, you find that these two, you find that can become the perfect square now. So 25 can become 5 square, and 16 can become 4 square. And then, of course, 5 square a square, you can group become square of 5a, and this one can become square of 4b. And as a result, you'll find that this one is also the format of square minus square. And you know that for square minus square, that means you can break down to 2 factors. We use the 5a and 4d to form 2 factors. One is 5a, one is 4b. And for the square minus square, the result must be 1 plus 1 minus. So that means this expression can break down to 3 factors, okay? 3 factors. 3 times 5a plus 4b times 5a minus 4b. Now, we consider this example. For this one, you know that is the square minus some square minus 1 here. But you know that the square the same. The square also control the p minus q only, but not 49. So that means this square is not the whole square. Not the whole square. So that means the first job, you need to make the 49 become the some perfect square. That means become 7 square. And p minus q square and minus 1. And 1, you should know that the same as 1 square. As a result, both are square, so we can group together, become 1 square. 1 square, overall take square, okay? So that means 7 times 3 minus q, and the whole take square, and minus 1 square. As a result, it becomes another square minus square. So we can use these two to form 2 factors. So one is 7p minus q, and 1. Okay, we can use 7 times p minus q and 1 to because you know this square minus square, so we can use these two to perform 2 factors. We use 7 times p minus q and 1, and 1 plus 1 minus. And finally, you can break the bracket, so 7p minus 7q plus 1, and 7p minus 7q minus 1. And you'll find that in these 2 factors, there is no like term, so this one can be the final result. Then, this one. This one, so it seems that just like another square minus square, but be careful. This square only controls C only, but the square is not on 25. So when we perform, but you know that when square minus square must be the square of the whole thing. So when we want to perform the square minus square, that means we need to convert 25 to some square. You should know 25 can become 5 square. And this one no change. then the 5 square c square can group together become 5c square. Now, as a result, you find that it becomes the square minus square again, okay? So we can use these two to perform the two factors, okay? You find one is you find that is the a square minus b square format. So a, that means refer 5c, and for b refer this one. So 3c minus 1, 3c minus 1, okay? And 1 plus, 1 minus. But be careful that when I say, because it's a minus square, you minus the whole square. So when you break down the factors, this minus should minus the whole, 3c minus 1. So when you use minus here, don't forget you need to add the bracket. Okay? Finally, you find that these two are like terms, so you can sum together 5c plus 3c, you know that become xc, and this one minus 1, and then you need to break the bracket. 5c minus 3c minus 1, you find that plus 1. Of course, that also exists a like term, so you need to calculate this too. xc minus 1 and 5c minus 3c, you know that you should know become 2c only, and plus 1. Then this when xc minus 1 times 2c plus 1 is the final result. It is a factorization of these two expression. Now, there are some more examples for you to study by yourself. For example, when I say 1 minus 4x squared, you find that is 1 square minus square of 2x. Of course, can become 1 plus 2x, 1 minus 2x. And for the 16n squared minus 25m squared, because you know that these two squares control the n and m only, so the next job you need, the first job you need to make the 16 and 25 become 4 square and 5 square. As a result, it can become square of 4n and square of 5m, so that's why it can become 4n plus 5m times 4n minus 5m. Another example. In this example, in this one, okay, you find that 2k squared minus 72. Both of them are even number, so the first job you can take out the 2 first, and after take out 2, you find that it will become the k squared minus 6 squared. So that's why you can break down to k plus 6, k minus 6. So as a result, you find that there are 3 factors here: 2 times k plus 6 times k minus 6. And for this one, you find that 4 and 16 are both of a multiple of 4. So that means 4 is a common factor in these two terms, okay? So you take out 4 as common factor, so you find that only remain x squared minus 4y squared, and square can control the y only, so you need to become square of 2y, so that means become the x squared minus the square of 2y. So as a result, this one can break down to x plus 2y, x minus 2y, and then times 4 finally. In this two example, this time you find that square of x plus 1 and 4. And of course, 4 can become 2 square. So it is a square minus square format, so can use x plus 1 and 2 to form the factors. So you find that x plus 1 plus 2, x plus 1 minus 2 are the two factors in this expression. And you know that these two are like terms, so you need to sum together here, so become x plus 3 times x minus 1. And for this one, when I say 1 minus 9p plus q squared, the same. The square can control the p plus q only. So when you want to use a square minus b square, that means you need the square of the whole b. So the 9 you need to become 3 square. As a result, you find that this one, okay, is a square of 3 times p plus q, and 1 can become 1 square. As a result, you can use 1 and 3 times 3 plus q use this two to form these two factors, okay? And finally, it can become, after break the bracket, you find it become 1 plus 3p plus 3q times 1 minus 3p minus 3q. The same, okay? Because for you minus the whole p plus q, so when in this minus factor, don't forget minus the whole factor. So don't miss the bracket. So you need to become minus 3p minus 3q. And for these two follow-up question, so this is the same example, okay? So for 36x squared, 49y squared, the same, okay? The 36 you need to become 6 squared, 49 you need to become 7 squared. As a result, you'll find that it should be the square minus square of 6x and 7y. So you can form these two factors. And for part B, 64 can become x squared. So square minus square. So we use a and a plus b to form two factors, and minus the whole a plus b squared. So when you in the minus factor, you need to minus the whole a plus b. So as a result, you can form these two factors in the product. Now we have finished this part. We finished using the a squared minus b squared to perform factorization. We know that for all square minus square format can become a plus b and a minus b. A and b can be anything, can be number, can be any variable, can be some factors together, and also a and b can become some expression. Okay. Now we finished this part. That means we finished this part. We use the a squared minus b squared to perform factorization. So now it's your job. The first job, you need to finish the level 1 questions. Level 1 questions in exercise 2F. Right, it's the first job. And another one, you need to finish the online quiz in Moodle. So try your best. Thank you.